Hello everyone, we are solving problems on the Thevenin and Norton's theorem. In that, next question is determine Thevenin and Thevenin across AB. This is the given network. So here he is asking the Thevenin equivalent for across AB. So first find VOC. So here this is VOC. VOC is equal to Thevenin. Open circuit voltage is equal to Thevenin voltage. So this node voltage becomes Thevenin voltage. You can apply any rule. You can apply Ohm's law or by voltage division rule or nodal analysis. Okay, so I am applying by voltage division rule. So what is Thevenin? Thevenin is equal to same impedance. Okay, these two are connected in series. So what is the same impedance? 5 plus J5 by total impedance. What is total impedance? So these two are in series again. So 5 plus J5 minus J5 into total voltage. What is the total voltage? 50 at an angle 0. So if you solve this, you will get Thevenin is equal to 70.71 at an angle 45 degrees volts. Now to find Thevenin, replace voltage source with short circuit. Internal impedance of voltage source is 0. So that is short circuit. Replace voltage source with short circuit. Then circuit becomes like this. Okay. Here this 5 ohms and J5 are connected in series. This resultant is connected to this capacitor in parallel. So what is Thevenin now? Thevenin is equal to these two are in series. So 5 plus J5 and this combination is parallel to this minus J5 ohms. So J5 Z1 Z2 by Z1 plus Z2. So 5 plus J5 minus J5. So you will get Thevenin is equal to 5 minus J5 ohms. The Thevenin equivalent circuit is like this. Okay, voltage source in series with impedance. Ideal voltage source in series with impedance. This is the Thevenin equivalent circuit for given network. If you want to find out Norton, so I Norton is equal to Thevenin by Thevenin. Z Norton equal to Thevenin. So what is Thevenin? 70.71 at an angle 45 by 5 minus J5. If you solve this, you will get 10 at an angle 90 degrees amperes. Next question is find the Norton equivalent for the following circuit across the AB terminal. This is the given circuit. He is asking Norton equivalent across the AB terminal. So first replace this 1 ohm resistor with short circuit and then find ISC. Short circuit current is equal to Norton current. Now redraw this circuit. Then circuit becomes like this. Okay, if you observe here, this 3 ohm and 6 ohm are in parallel. So if you solve this, 3 into 6 by 3 plus 6, 3 into 6 by 3 plus 6, you will get 2 ohms. Okay, so again this 2 ohm combination of this equivalent is 2 ohms and this 2 ohms and 2 ohms are in series. So if you 2 resistors are connected in series, the equivalent is summation of 2 resistors. So 2 plus 2 is 4. Again this 2 and this 4 and this 4 are in parallel. If you observe this branch current is 18 amps. Okay, here this is current source. So this branch current is 18 amps. Whenever reaches to this node, this equivalent is 4 ohms. This equivalent is 4 ohms and this is 4 ohms. So current is divided equally. So this is 9 amps and again this is 9 amps. Now coming to here, this is 9 amps. Here 2 resistors are connected in parallel. We can apply current division rule. So by current division rule, what is Norton current? I Norton is equal to opposite resistance by total resistance into total current. So what is Norton current? 6 amps. Now find the open circuit resistance. Okay, so open this 1 ohm resistance and find the open circuit resistance. Replace current source with open circuit because the internal impedance of current source is infinity. Then circuit becomes like this. Okay, here it is open circuited, so we can neglect this 10 ohm resistance. Now this 2 ohm and 4 ohm are connected in series. So what is equivalent? 2 ohm plus 4 ohm, 6 ohms. 6 ohms and 6 ohms are connected in parallel. If two resistors are connected in parallel with equal value, then what is equivalent? The resistance by 2. So 6 by 2, you will get 3 ohms. So the circuit becomes like this. Okay, this is R1. This 4 ohm, 2 ohm are connected in series. So the equivalent is 6 ohms. You will get like this. Again, so this is disappear. 6 ohms, 6 ohms are in parallel. So if two resistors, equal resistors are connected in parallel, the equivalent is divided by 2. So 6 by 2 is 3 ohms. So this is 3 ohms. Again 3 ohms and 3 ohms connected in series. So what is Norton equivalent? Rn equal to 3 plus 3, that is equal to 6 ohms. So this can be written as R Thevenin. The Norton equivalent circuit of this 1 ohm resistor is, across this 1 ohm resistor is like this. Okay. To calculate VThevenin, so VThevenin is equal to, by source transformation, I Norton into R Norton, 6 into 6 is equal to 36 volts. For suppose, if we want to calculate current flowing through this 1 ohm resistor, so this is 1 ohm resistor. So by current division rule, what we are getting, I1 ohm is equal to opposite resistance. What is opposite resistance? R Norton, that is 6 by total resistance 1 plus 6 into 6 is equal to 36 by 7 amps. Next question is, find the VThevenin and RThevenin across the terminals AB for the following network. This is the given network. So he is asking Thevenin voltage and Thevenin resistance across these two terminals. Okay, so here this is open circuit. This node voltage becomes not Thevenin voltage, because here it is a voltage source. If there is a voltage source, we need to find out voltage across this 6 ohm resistors, that is voltage at this node, let it be V1. So this is V1. If you observe this, the current flowing through this 10 volt source is 0. So if it is 0, this is open circuit. If it is open circuit, these 3 ohms and 6 ohms are connected in series. If these two are connected in series, the equivalent is 9 ohms. So here it is 9 ohms and this is 9 ohms. This is current source. So the current source value is, this branch current becomes 20 amps. If 20 amps coming towards to this node, here it is 9 ohms and this is equivalent is 9 ohms. So what is the current flowing through this branch? So current is equally divided. So 10 amps and this is 10 amps. So this is 10 amps. Here also this is 10 amps. Now what is V1? V1 is equal to IR. So current is 10. Resistance is 6. So you will get, sorry, this is 60 volts. So by KVL, so apply KVL for this loop. What is KVL? V1 is equal to 10 plus VThevenin. From this, VThevenin is equal to 60 minus 10. So VThevenin is equal to 50 volts. To find RThevenin, replace voltage source with short circuit, current source with open circuit. Then circuit becomes like this. Voltage source is replaced with short circuit, current source is replaced with open circuit. Okay, this is open circuit, so we can neglect this 10 ohm resistor. This 3 ohm and 9 ohm are connected in series and this resultant is connected to the 6 ohm in parallel. So RThevenin is equal to 6 into 3 plus 9 by 6 plus 3 plus 9. You will get 4 ohms. Okay, this is, you can take R Norton. So the Thevenin equivalent circuit across the AB is like this. Okay, for if you want to find out Norton, so I Norton is equal to VThevenin by RThevenin, 50 by 4 equal to 12.5 amps. Okay, in the next video we will discuss some more problems on this concept. Thank you for watching.